Hello and welcome to another wonderful episode of Limits with Mr. Smith here. I know we're probably making limits your favorite topic, which is great. We're just going to look at some graphically, and as you can see, we've got a little graph over here, and then a bunch of limits over here. So if you're in my class, this is very similar to what your test might look like. Who could this be? Mr. Hall, what's up, brother? Anyway, sorry about that. I'm very, very popular, you must know. Anyway, so doing limits graphically should be very easy. You just gotta, hopefully you're looking at these real quick while I'm rambling here, and you can answer most of these in your head. But we're gonna run through them. So, limit as x goes to -6 of f of x. Well, here's f of x over here. Here's -6 right here. So we want to know as x gets close to -6 on the x-axis right here, what's this graph doing? And this graph is moving towards this dude. What's up, Shima? Thanks, buddy. Anyway, it's a very busy morning here in the portable. On the graph, and this is all you're doing. X is getting close to this number right here, -6. Where's the graph getting close to? Well, it's getting close to this hole here. Now, even though there's no point there, the y value of that hole is 3. Now, you can see that right here. Right there, to 3. Okay? But there's no point there, but it doesn't matter. As long as the two ends are going to meet each other, that's what the limit exists. Or that's what the limit is. The limit exists. So the answer to this one is 3. And again, you can imagine this as if you're driving on a road this way and someone's driving on the road this way, and they're both on the function. As they approach 6, are they going to hit each other? If yes, then the limit's there. Doesn't matter if there's no point there or not. As long as they are both infinitely close to this point, which they can get, the limit's going to exist. So limit x goes to -3. Well, that's right here now. Here's -3. And again, here's the graph, headed to here. And here's the graph headed to here. Now, when it gets to -3, it jumps up to this point right here. But that doesn't matter. Again, remember, x going to -3 means what's happening as x approaches right before it gets there, but not when it gets there. So right before it gets to -3, we are still approaching this point down here, -1. And that's the answer. And again, you can see, if someone's driving on the road up here in this part, and someone's driving on the road this way, and they're headed towards each other, they're going to collide at -1. What's up, Sabrina? Pretty good.
Can I leave this with one second?
Absolutely. Nice jersey. Alright, limit as x goes to 0 of f of x. You can see here, this is supposed to be an asymptote. On the left-hand side, this graph is just going to go up forever to positive infinity. This side's going to go up to positive infinity. These graphs are never going to touch, but the closer x gets to 0, the closer values you pick to 0 here, either on the left or the right side, these values get bigger and bigger and bigger and bigger, and eventually they're just going to run off the page. But they go to infinity. Like, no matter how close you get to 0, there's going to be a point way up there somewhere, and it gets closer and closer to infinity on both sides. So that's the answer. That's what happens when you have a vertical asymptote. Limit as x goes into 4 from below. Well, 1, 2, 3, 4. Here's this. This little minus here means from the left-hand side, so that's back here, and we're headed to 4, which means we're only concerned about this part of the graph up here. If you're on this part of the graph and you're driving along here, right before you get to 4, you should be expecting to get to this point. Even though nothing happened, there's an open circle there. Right before you get to 4, you are headed towards that point. And you can get as close to this point as you want by picking values as close to 4 on the left-hand side as you want. And that's really what a limit's saying. If I pick x close enough to 4, I can get as close to this hole as I want. And that happens at 3. Limit as x goes to 4 from above. Well, now we're interested in the values on the right-hand side of 4. So which means we're on this part of the graph. And if I pick points closer and closer and closer to 4, but on the right side, I'm going to get y values closer and closer and closer to this point down here. And that is at -3. So again, we're looking for the height that it's approaching. Not that it equals there, but that it's approaching. Alright, now since the left-hand limit equals 3, that's up here, we're going to 3, and the right-hand limit equals -3, the limit as x goes to 4 of f of x just doesn't exist. There's nothing wrong with that. Does not exist. And again, you can tell us because if someone's driving on this road, someone's driving on this road, and they're headed towards 4, they're not going to collide with each other, so there's no limit. And the limit as x goes to -infinity, that means x is going way back. I mean, x is just going back here forever. Forever, forever, forever. Where's the y value getting close to? Well, if you look up here, I've put this nice dotted line, which is supposed to signify a horizontal asymptote. And that's exactly, when you see limit x going to -infinity or limit x going to positive infinity, that's the same thing as saying, what's the horizontal asymptote? That's exactly what they're asking you for. And negative infinity is on the left-hand side, so back here. And you can see this graph, as x gets more and more and more negative, this graph should get closer and closer and closer to this horizontal asymptote, which is at 1, 2, 3, 4, 5. There you go. All right, so let's try another one here. If you want, you could probably pause this video and just do these real quick to make sure you know what's going on. But if not, I'm going to answer them now anyway. So hopefully you paused it and you tried them. But let's go over the answers. As x goes to negative infinity, here's x going out this way, negative infinity. The graph is headed up in this direction. So it looks like it's going to keep on going up forever, which means the further x goes back, the higher the graph goes. The graph goes to infinity. Limit as x goes to positive infinity. Well, that's on this side. X is in this direction. Morning, me. Which means our graph is headed in this direction right here, and it's going to get closer and closer and closer to this horizontal asymptote. And again, as x goes to infinity or negative infinity, all I'm asking you for is a horizontal asymptote. And on this side we have one at what, 6, 7, so 7. Limit as x goes to negative 3. That's here. Morning. Thank you, Aisha. On the left-hand side, this is going to go up to positive infinity, and on the right-hand side, it's going to go down to negative infinity. Which means, since both sides aren't approaching the same thing, this doesn't exist. Limit as x goes to 0. This is an easy one. As x goes to 0, that's right here. Okay, we're zeroing in. There's just a point there, and that's what the answer is, negative 3. Because the graph is continuous there, so it must just approach what it equals. Limit as x goes to 1 from the right-hand side. That's right here. X is getting close to 1, so this is getting close to this point, which is at 2. As x goes to 1 on the entire limit, that's both sides. Well, both sides don't approach the same thing. They're not going to collide. It does not exist. Okay. X goes to 4. What's up? It's all good. Where's 4? 4 is right here. You can see both sides are approaching this hole here, which has a y value of 4. I'm talking to my computer. It doesn't matter. Say hi. Say hi to everybody. I think we'll get like 4 views. Hey, 4 views on this one maybe. And as x goes to 4 from below, that's on the left-hand side here. That's just approaching this hole right here. And that's, since the limit exists, both sides approach the same thing, so the answer is 4. Alright, there you go. This is me and Sabrina saying goodbye. Say goodbye, Sabrina.
Goodbye.
There you go. All right.